This one silent feature in C++ can completely change your program without asking you. It's called implicit type conversion, and if you're not watching it closely, it could burn you. From hidden bugs to performance hits, this is one of those things that C++ just does even when you don't tell it to. Today we are going to break it down with real examples and show you exactly how to stay in control. Hey everyone, welcome back. Today we're diving into a fundamental but often overlooked part of C++, implicit type conversion. You might not notice it happening, but it's there, quietly shaping how your program behaves, for better or for worse. Let's start by answering the big question: what is implicit type conversion in C++? In simple terms, implicit type conversion happens when the compiler automatically converts a value from one data type to another without you explicitly asking for it. It's kind of like when you ask someone for a cup of coffee and they bring you a latte. You didn't ask for it, but they figured you'd want it anyway. It's done for convenience, but sometimes it's not what you actually wanted. So how does C++ decide when to do this? Let's break it down. Imagine you have two variables like this. If you write double result equals a plus b, then C++ sees a is an int but b is a double, so it automatically promotes a to a double before the addition. That way the operation is consistent. This kind of conversion, where smaller or simpler types are promoted to more complex types, is very common. It's part of what we call the usual arithmetic conversions. The key rule here is, when types in an expression don't match, C++ converts them to a common type that can represent all the values involved. Okay, so the compiler is being helpful. Why should we care? Well, here is why. Sometimes the compiler's assumptions can lead to subtle bugs. Let's look at a common example. If you're expecting x to hold 255, then this may surprise you. Depending on how char is treated on your system, signed or unsigned, you might actually get -1. That's because when a signed char overflows and gets implicitly converted to an int, you can end up with an unexpected negative number. This is exactly why understanding these conversions is critical. Let's take another example. Here, short is implicitly converted to int before the addition happens. This is called integer promotion. It promotes types smaller than int to int or unsigned int. The problem arises when you're mixing signed and unsigned types. Take a look at this. At first glance you might think this prints yes, because -2 is obviously less than 1, but it actually prints no, because I is implicitly converted to an unsigned int, and in unsigned representation, -2 becomes a large positive number. That's a classic pitfall caused by implicit conversion. Now let's talk about floating point types. If you combine a float and a double, the float gets promoted to a double. Here f is implicitly converted to a double. No big deal, right? But if you're working in a high-performance system where precision or performance matters, these conversions might cost you, in either CPU cycles or accuracy. Implicit conversions can also lose precision, like here. The compiler might warn you, but it will still do the conversion unless you explicitly stop it. You'll lose some digits of precision in the process. Something else to watch out for is literals. For example, here both operands are integers, so you get integer division, which is free. But if you wrote this, now you get 3.333 etc. because 3.0 is a double and 10 gets implicitly converted. Subtle difference, but very different result. Always be clear about what types you are using when you work with literals. So far we've talked about built-in types, but implicit conversion also applies to user-defined types, like your own classes. Let's say you have a class with a constructor that takes an int. Now you can write this. It works because C++ implicitly converts the int to my number using that constructor. Pretty cool, right? But it can get dangerous. Let's say your class also has a constructor that takes a double. Now the compiler might have trouble choosing which one to use if you write this. And here is the kicker. You might not even realize an implicit conversion is happening. To prevent this, you can mark constructors with explicit keyword. Now, if someone tries to do an implicit conversion, they will get a compiler error. It forces them to be intentional. Classes can also define conversion operators, like this. Now, an object of my number can be used as if it were an int. Again, cool in some cases, but very easy to abuse. Imagine you have multiple conversion operators. One to an int, one to double, maybe one to string. Now, which one gets picked depends on context. This can create ambiguous or surprising behavior. Just like constructors, you can mark these conversion functions as explicit in C++11 and later. That way it can still be used, but only if the conversion is written explicitly by the programmer. Here is another place where implicit conversion gets interesting. Function overloads. Imagine you have these functions. If you call do something with a char, what happens? Well, it can be promoted to an int or even converted to double, but the compiler will pick the overload that's the best match, which is actually the int version here. But now let's say you add this. Things get trickier. Char can be converted to float too. If the match is ambiguous, the compiler will throw an error. So, in overload resolution, implicit conversions can make function calls ambiguous, especially when too many overloads exist. This is why it's important to understand not just that conversion happen, but how they are prioritized. Alright, so what should you take away from all this? First, understand that implicit conversions are part of how C++ works. They are not evil, they are actually really helpful when used wisely. But here are a few best practices. Avoid mixing signed and unsigned types, unless you are 100% sure in what you are doing. Use explicit for constructors and conversion operators that you don't want to be called automatically. Watch out for narrowing conversions, especially when converting floating point numbers to integers or double to float. Be careful with literals. A free is not the same as 3.0, and neither is the same as a free char. Don't overload functions unnecessarily. Keep overload simple and distinct enough that implicit conversions won't confuse the compiler. To wrap it up, implicit type conversion in C++ is like autopilot. Most of the time it gets you where you need to go, but if you're not paying attention, it might land you in the wrong place. Understanding these conversions means you are writing code that's safer, more predictable and easier to debug. So the next time you're scratching your hand wondering why is this happening, take a look at the types involved. Thanks for watching. If this helped clarify things for you, give the video a like, subscribe and check out the playlist on the screen. See you in the next one.